Hello and welcome to my shop. This is the old shop, my electronics workbench, which as you can see is very clean. Here I have an ECG, the back of an ECG lead. So I'm working on a project involving pulse and blood pressure and things like that. And so I needed a way to measure my blood pressure periodically and get that data electronically. So you do that by you measure blood pressure using a sphygmomanometer. Everyone's probably seen one of these things. It's got a cuff that goes around your arm and it tells you your blood pressure. There are a bunch of devices that I could find on the internet that would sort of give me that data via Bluetooth or allow me to see it in some sort of custom app. That's not quite what I wanted to do because I wanted to be able to actually start it. Ooh, it had some residual charge. I wanted to actually be able to start it on a periodic thing and get the data electronically without having to hack some custom app or reverse engineer some Bluetooth protocol. So I thought I'd just start off by buying a cheap one off Amazon. This was like $30 and seeing if I can open it up and get the readings out of it in a way a computer can understand. But before we sort of take this thing apart, it's probably worth understanding how one of these guys work. So you take the cuff, you put it around your arm, and the cuff slowly sort of inflates. And what it does while it's inflating is it's over your radial artery, no, what is this? Brachial artery over your arm. And as it inflates, it's constricting or it's putting pressure on that artery. Now the artery is carrying blood that's under pressure itself. It's under pressure when your heart is at rest, but then it's under increased pressure when your heart contracts, when your ventricles contract. So as the cuff inflates, it gets to a certain pressure where its pressure is equal to or greater than the pressure of the blood sitting in the artery and causes the artery to sort of collapse a little bit. And when it does that, it causes turbulence inside the artery and that causes a sound, the sort of whooshing sound of the blood running through the constricted artery. And this device has some sort of meter in there that hears that whooshing sound and that gives you your diastolic blood pressure. That's the pressure that your blood's at in between ventricular contractions. Anyway, so it keeps on contracting to a point whereby it completely constricts that artery and no more blood flows, so the sound stops. That's your systolic blood pressure. That's the pressure at which your blood is under at the peak of systole, or the contraction of your left ventricle. It's been like 20 years since I've studied this, so hopefully that's all right. Anyway, so that's the basic idea. It inflates, it listens for your heartbeat starting, and then when it stops, and that gives you your diastolic and systolic pressure. Anyway, enough talking. Let's take this guy apart and see what we can find. All right, what do we have in here? All right, let's go through the mechanical side first. So this is obviously a pump. It creates the pressure. The cuff goes in here. Is this a solenoid or a pressure sensor? It goes here as well. So I'm guessing, okay, this is a pump. Generates positive pressure, probably detected by this thing. Maybe this is just detecting the pulse. Sorry, I have a loud dog outside. One moment. All right, so, let's have a look. Okay, nothing seems to be affixed in here. Oh, okay. I think this is like a pressure release valve. Like once the measurement's done, the air's got to come out. There's probably a check valve in there. So this lets the air out and this is the pressure sensor. All right. Well, I was kind of hoping to find some sort of, let's get a better light here for me at least. Some sort of micro with a separate memory chip. That way I could interrupt those lines. But here you see one of these custom chip on board under a blob things. But up here, let me zoom you in using my manual zoom. See if you can see this. Maybe I'll turn this light off so it doesn't cast as harsh a shadow. there are some interesting looking points up here. All right, so what do we have here? Pointing device. Okay. Ground, VCC, TCK, TDI, TMS, TDO. Okay. This is a JTAG port. That's pretty awesome. SI, SO, CS, GND, VB. So ground. And what's VB versus VC? Anyway. This is some sort of serial port. I wonder if it's an SPI. I don't see a clock. It could just be a standard sort of serial port. What would CS be? Chip select? It ain't new. But this is looking like it's going to be a lot easier, famous last words, than I thought it was. The JTAG obviously is interesting. Do I have well, I know I have a JTAG adapter, but how would I hook it up to my computer? To go from USB-C to JTAG, I think I'd require a very long chain of dongles to get to my old JTAG adapter. I don't even know if it's been a while since I used that. I think, the last thing I used JTAG on was this guy here. My weird clone of a HP 42S with my own sort of custom programming language that got ripped up by stuff. Anyway, that's a walk down memory lane. Let's see what we can see on these ports. I have my oscilloscope up here. I will point you at that and let's have a look. So I'm going to take you back down here for a second so we can actually see the device in action before we go to the jump straight to the oscilloscope. So I've got it plugged in. It looks like it's asking me to set the year 2014, January 1st at noon. That is exactly the time and date right now. All right. Let's plug in the cuff. I don't know if you can see the screen. It's asking for user 1. Well, it doesn't like not being on an arm. Anyway, that's good enough. It inflates. If it's sending something on the serial port, we should be able to see it. Alright, so got a probe. Let's see if I can find another ground point to hook into so I can ground my scope, or at least have the same ground reference for this signal. Alright, let's get out the multimeter on continuity. Alright, ground. That's ground, right? It's not ground. Battery? No. Alright, the power adapter shares the same ground. Alright. Alright, anyway, where were we? Reading serial data. So I said the ground could be read hooked up to here. Data on serial out, why not go for broke? Looking at the scope, I just saw a little spike. That was noise. I'm looking at serial in now because I don't know which way it is referencing in versus out. Again, a little noise spike on the scope. Well, let's look at chip select. I assume that's what CS is. Maybe it is clock signal. Excuse me. You're not seeing anything on here either on the scope. So I'm guessing, well, I'm getting no voltage on it, so it's probably a high impedance input telling something to select the output is my guess. All right, I'm running out of what I can hold with hands, so I'm going to solder some leads onto here and see if I can break this out a little bit more. So let's warm up the old soldering iron. So once I've got these attached, I'm going to try and tie CS either high or low and see if that enables a serial output, or at least some sort of output. Okay, VB is first. Oh, let's tin these pads. Didn't really wet very well. It's probably lead-free solder, and I'm using the lovely lead kind. I love the smell of lead in the morning. Probably could have found my JTAG adapter by this point. Alright, we should not need the iron, so I'll turn that off. I should have had the power off while I was doing this. Now, I just, the other day, made myself a little 3-way breadboard on a lovely piece of green plastic. I was debating whether or not to put a ground plane, like a big metal ground plane underneath it, but I decided against it. Anyway, mega breadboard. Ground. VB, which seems to be the same as VCC, maybe. Which one was yellow? I forgot. Yellow was SO, I believe. I'll double check. Yellow was SO and white was CS. Let's pop it over here. Alright, let's move my scope to the breadboard. Alright, I'll have to cannibalize from a circuit back here. Alright, let's attach the scope to ground. And to SO. Is that a good enough signal? Alright. Alright, so when I turn the machine on, ooh! It did give, when I turned it on, let me show this to you. I'll just go handheld for a moment. I'm just in sort of rolling mode here. Turn it on. Get some wiggly noise. Whoop. Positive pulse on SO. That's a good sign. You get to see all of my half-completed projects. All right. Let's see what happens if we tie. I'm going to try chip select CS, I assume that's what it is, to ground. Let's see if that changes anything during boot up, or it gives me any signal right now. I'm watching the scope. Nada. Let's try off and on again. The laborious process of reverse engineering, or at least hacking. Noise, pulse, Try setting the date. Date is set. Nothing. User 1. Should be taking a measurement now. Nothing too exciting is happening on this output line. Let's wait for it to error out. It's errored out. Right, nothing. I wonder if it's not sending anything on the serial out because it's erroring. So I wonder if we take an actual measurement, whether we'll actually get some serial data out. If not, we can try with the thing tied high rather than low. All right. I'm watching the serial output. I think I'm just staring at the noise in the serial output right now. I've zoomed in a bit. I'm not seeing any data there. Zoom out. 134/94. That is not great. That is not good at all. Mildly hypertensive. I'm going to call that YouTube anxiety. Well, I didn't see anything on the output on serial. Oh. No, I thought I saw something for a second on the serial output. I didn't. Let's try tying it high with a resistor. What is a reasonable resistor value? I don't want to fry anything. There's a 100k. Yeah, tie it high via 100k. That should be good enough. Right. 100k. You can't see that. Focus. You believe me, it's a resistor. All right. All right. Tied CS high. Let's see if we see anything on the scope. Whoop. Zoom. Focus. All right. Turn the guy on and see if we see. That's just noise. User 1. Nothing. Good news is my blood pressure has gone down a little bit. All right. We are half an hour in. I have not made a ton of progress. Well, I guess I have. I've found a bunch of ports in here that look interesting, but yet haven't given up the goodies. I mean, failing, if I can't actually work out how to get data out of this thing, it's not actually that hard to build what it is. It's just a pump, pressure meter, and a valve to release. I could totally just take those parts off and yeah, and that's probably even easier, is just controlling all of those parts from an Arduino. I should probe around the rest of the board and see what else there is, but I might call this quits for now and see if I can find a JTAG adapter and get that hooked up. All right, catch you soon.